This is from the AddMaths book, page 68, exercise 4B, and it's question 3. In question 3, it gives you this: x and a squiggle, b, 6 and 0.2, and then you've got to find p, x equals 4. First thing we've got to do is work out what all of these things mean. So let's look at this bit here first of all. The x, squiggle, b, 6 and 0.2. So to work out what each of these things means, if it's b here, that b means it's a binomial probability. And after that, the next two things, this is n, and n is the number of trials we're doing. So this means we're doing something 6 times. And the number over here, this is called p, and it's the probability of getting a success. So we're going to call p the probability of success. The question is saying find the probability x is 4. So we've got some experiment. We're doing something 6 times, and every time we do it, the probability of getting a success, whatever that is 0.2. And that's constant all the time in all the 6 goes we have at doing this experiment. They want us to work out the probability of getting exactly 4 successes. To do this, you need to know the following formula. It is not given to you on the exam paper. So this formula you need to learn. The probability of getting any value here, I'm calling it r, is n, choose r, and that n is the same as the n here, p to the power of r, p is this p here, and then 1 minus p to the n minus r. It's absolutely crucial that you remember that. So when I do in any question, I'd actually write down first of all what n, p and r are in the question you're doing. So in part 1, n is the first number in the bracket. N is 6. P is the second number in the bracket. P is 0.2. And r, well, that's what we're asked here. It's this number here. So that's going to be 4. So using that information, we now just stick these numbers in that formula. And we're working out probability x is equal to 4. And it's n, choose r, p to the power of r, 1 minus p to the power of n minus r. So we've got here 6, choose 4, 0.2 to the power of 4, and 0.8 to the power of 2. Then it's a case of typing that in your calculator. Now different calculators do this choose thing different ways, but you're looking for an NCR thing. Sometimes it's a button, sometimes it's hidden in your menus somewhere. So I'm going to do here 6, choose 4, multiplied by 0.2 to the power of 4, multiplied by 0.8 squared. And my answer is 0.0154. So I'll write that one down here, 0.0154. That's the answer to part 1 of this question. Second part of the question, part 2, is asking for the probability x is less than or equal to 1. So this is saying, what is the probability that the number of successes in these 6 goes, because n is still 6, that hasn't changed, what is the probability that the number of successes we have will be less than or equal to 1? So that's asking for either we get no successes or we get 1 success. And note, when I said or, I put a plus sign down. So we need to work out the probability of getting no successes, the probability of 1 success, and then add them together. So we're still using the same n and p value as we did before, and we're still using the same formula that we had before. So first of all, the probability x is 0, using the formula up here, is n, choose 0, p to the power of 0, 1 minus p to the power of 6 minus 0. Then over here I've got to add this one on. It'll be n choose 1, 6 choose 1, p to the power of 1, 1 minus p to the power of 6 take away 1. So I get these sums here. Now, anything choose noughts is 1. It's useful to remember. So that bit there is just 1. Anything to the power of naught is always just 1. So this bit here is actually the same as just 0.8 to the power of 6. Okay, this bit here it's worth doing on the calculator. So, the first bit, when you work this bit out, you should get 0.262. When you work this bit out on your calculator, you should get 0.393. When we add those together, you should get an answer of 0.655. And that is question 3 finished.